Okay. Relative risk and odds ratio. When you see these in publications, you're going to see RR and you're going to see OR. I started seeing these about 10 years ago, and I've never stopped seeing them since then. They're very trendy right now, and I think they're going to be with us for a long time. I want you to click in the RR cell so you can see the computation. Go ahead and click in the RR cell. Click in the relative risk cell. Notice it's 1.47, and I want you to make sure you understand what that means. So in order to calculate that, it took C6 divided by C7 and divided it by D6 divided by D7, if you will. C6 divided by C7 over D6 divided by D7. So mathematically, if I may be mathematical again, I think this helps me mathematical a little bit with this. What the relative risk is, what relative risk is, this is the difference of the p-hats. Relative risk is the ratio of the p-hats. It's how many percent bigger one is than the other, or smaller, depending on what the case is. So in other words, when you divide this p-hat by this p-hat, and you actually use the correct sample sizes. That's one thing we didn't do over here. We just divided the percentages without weighting it for samples. If you actually weight it for samples, you get the number 1. You can't see that. You get the number 1.47. 1.47. Now, what does that mean, 1.47? What does the 1 stand for? And you got to think not statistically now. Think mathematically. You got to turn that part of your stat brain off and go strict math. What does the 1 stand for if you're dividing that 6.3 by the 4.29? What does the 1 stand for? I'm 6 feet tall. My son's 4 feet tall. If I divide my height by his height, I get 6 divided by 4, or 1.5. What does that mean?
The difference between your height.
It's how much bigger I am as a multiplication factor. Aren't I 150% bigger than him? So what does the 1 stand for? 100%. What does the 0.5 stand for? The 50% additional that I am. Does that make sense? I'm sorry. I always bring it back to something non-statistical. So 6 feet, 4 feet, 1.5 times him equals me, so I'm 150% bigger. So that means that the relative risk, I don't know why it's called relative risk, it's just the word they use, is 147% greater in the acetaminophen group versus the non-acetaminophen group. Which, actually, excuse me, I said that wrong. The relative risk is 140% of the non-acetaminophen group, which means it's 47% greater. Now, they use 46 in their calculation. I can't get it to equal exactly 46, but I'm going to let them, it's probably a rounding error. 46% greater, 47% greater. So that's where they got that 46% from. And every other one of those percentages is also tied to that relative risk idea. Everything else. Okay, so far? Now here's the problem. They were slight bit incorrect with that, because relative risk itself has a confidence interval. It does. It's got a plus or minus. It's actually, to be more correct, they shouldn't say it's 47% greater. They should say it might be as little as 27% greater or as high as 69% greater. Now the thing about it is, both of those imply more than 100%. So they are correct in statistically stating the risk is higher. The risk is higher in the one group. It's at least 29 or 27% higher. Might be as high as 69% higher. That's all. That's the number they're talking about in those. They very rarely will use the difference in the percentages. They'll use the quotient. Why is it again? Why the quotient, not the differences? Why didn't they use the differences?
Because it's a percentage.
Well, technically, that's a good answer. Whoever just said that. Was that you, Jack? That's a good answer. I like that very much. These technically are percentages too, 147%, technically speaking. But why not use the 2%?
Because it's not eye-popping?
It's not, 2% is so small. 47% pops out at you, and 47% you say to yourself, that's a huge difference. That's almost 50% more. That's how big Sean is compared to Max. 50% bigger. What sounds more impressive? I'm 50% bigger than my son, or I'm 2 feet bigger than my son. Right? 50% bigger pops a lot more. It pops a lot more. Now, I'm not saying that this is why they did. This is why I think they did. It's going to sell more headlines. It's going to make us believe that headline more. But the problem is, it doesn't really pan out when you look at the numbers, because the numbers aren't anywhere near as impressive as the percentages are. And this is the problem with using percentages that are very, very small and dividing them with each other. And this is a heads up. It's a math concern more than anything. When you've got two very small percentages like we did, you can make them look very large by dividing them. If one is, it's IQ all over again. Give a 3-year-old kid an IQ test. If that kid tests as a 4-year-old, what sounds more impressive? That he's 1 year ahead of where he should be, or that he's got an IQ of 133% of what it should be? Which one sounds more impressive? Of course the second one does, right? Because 4 divided by 3 is 1.33. That's relative risk. But simply going, he's 1 year ahead of where he should be, is 4 minus 3, which is 1. Risk sounds way, way more impressive. Just make sure when you read the risk, you promise me these two things. But always consider the margin, which should be there, of course. Always consider the margin, and always make sure you know the original data that it came from. It's actually hidden on the screen. It's back on the side. That having been said, did I answer that question?
Why are the margin of error and the relative risk
Not symmetric?
Yeah.
Now, I always want the easy answer? It's based on a radical, a square root, not a linear average. So if you're interested, and I highly encourage you to, you can go ahead and click in the cell and you see the count. Oh, I've got it referring to a different cell. The messiness is somewhere. It's not a symmetric. So Denali noticed that the margin of error on the relative risk is not symmetric. It's different top and bottom. That's a function of, I had to Google that myself. It's a function of the margin of error of a relative risk. It is not symmetrical. It's not a plus or minus in the symmetric sense. It's a plus or minus, but because of the calculation, you get asymmetry. That's the best answer I can give you. We'll get into the odds ratio tomorrow. I'll build a warm-up on all three of these things we can look at. Because the odds ratio is very, very similar. As you can see, it's very similar to the relative risk, and it's just a difference in how the original number gets calculated. I'll build a warm-up course on Thursday that ties that in. And then we'll do our experiment that I was going to do today, which is go out and walk around the building and collect some data. Okay, friends, that's it. That was a lot of terms today. I apologize. You looked frazzled. Apologies. We'll talk to you next time, yes?
Yes.
Start the project. Don't forget this there. Danielle, talk to me. Yes, let's get that question answered.